So I've got one last theorem to prove that goes along with parallel lines, and that is the consecutive interior angle theorem. So the consecutive interior angle theorem is kind of like the black sheep here of the theorems that have to do with parallel lines, because all the other ones are nice and they talk about congruence, and so it's just linking things together. And then we get to consecutive interior angle theorem, and there's a whole bunch of work we have to put in because I'm going to talk about angles being supplementary. And so what it says is that just like all the other theorems, it starts off with if two lines are parallel, then the consecutive interior angles are supplementary. Alright, so this one's going to require me to put in a little bit more work. I'm going to have to talk about angle measures and stuff, but this still won't be too bad. So, just like before, I'm going to draw a diagram to work with. What I need is a diagram with two lines in it that are parallel to each other. So I will mark them as parallel. I will call this line P and this line Q, and they get intersected by transversal T. I will label all my angles that I have to work with. And then, alright, so what do I want to prove? So my statement says if two lines are parallel, which I have, then the consecutive interior angles are supplementary. So what are my consecutive interior angles? And those are these angles here, either 3 and 6 or 4 and 5. And so those are two pairs of angles I want to prove supplementary to each other. I just need to pick one of them. And so when I write my given and my prove, my given is just that P is parallel to Q. My prove will be that, let's go with 3 and 6. That angle 3 is supplementary to angle 6. That is what I'm trying to prove. Okay. So what we're going to see here are us using a couple tools that are going to be very commonly used, like kind of in this order, to talk about supplementary angles. Whenever I want to prove things are supplementary, chances are that if I work my way backwards, I'm probably going to have to talk about their measures and them adding up to 180 degrees at some point. So that's going to be my goal here, is to talk about these. So, but first, no thought. Let's just put the given down, and then I can put some thought into this. All right, so 3 and 6 I want to prove supplementary, and the question is how I'm going to do that. And still, the only tool that I have available to me to start this off is to talk about my corresponding angle postulate. So I'm going to pick two angles that are corresponding to each other that'll be congruent. So for example, let's go with 2 and 6. So 2 and 6 will be congruent angles because they're the corresponding angle postulate says that if the two lines are parallel, then the corresponding angles are congruent. So the question is, how can I get to the statement of 3 of 6 being supplementary? And the answer is, well, 2 and 3 happen to be a linear pair. And what do we know about linear pairs but that they are supplementary to each other? Well, so if 2 and 3 are supplementary, and 6 is congruent to 2, it seems like there's probably some like substituting or something I can do here to get a statement along the lines that 3 and 6 are supplementary to each other. So that's going to be our goal. That's what we're going to be working towards. So let us start off with that. Let us start off by linking together these sets of angles up here on P and the set of angles down here on Q. So statement number 2 will be that angle 2 is congruent to angle 6. So my reason for that is if two lines are parallel, then the corresponding angles are congruent. There we go. Okay. So that's great. That's how I'm going to link these together. Let me check myself though really quick. So if two lines are parallel, where did I say that? It was up here in statement number 1, which then allows me to say then the corresponding angles are congruent, which is what I said here in 2. Okay, great. So that all matches up. So now I need to talk about supplementary angles in some way, shape, or form. And what we said is that we're going to link together 2 and 3 here. And so how do I say that these two angles are supplementary? Well, I'm going to use my diagram here. So I know that these two angles are supplementary because they form a linear pair. And linear pairs are one of the two things that I can assume from the diagram. So just by looking at the diagram, I can tell that angles 2 and angle 3 are a linear pair. And so I will say that. So statement number 3 is that angle 2 and angle 3 are a linear pair. And my reason for that is just assumed from the diagram. Okay. And so now, what do I know about angles that are a linear pair? The thing is that I know that they are supplementary. And so I can go on to statement 4 and say that angle 2 is supplementary to angle 3. Okay, so that's statement 4. My reason for that is the linear pair postulate that says that if two angles are a linear pair, then they are supplementary. Okay, so let's just check to make sure the statement makes sense. So it says that then they are supplementary. That's what I'm saying right now. If two angles are a linear pair, where did I say that? I said it up here in 3. Okay, so now would be a really great time. Like if I had a way of taking angle 2 and like substituting it in, or sorry, angle 6 and substituting in for angle 2 here, like I'd be golden. However, my substitution property is the substitution property of equality, so I really need to talk about equality. I need to talk about an equation. So the way that I'm going to get through this is I'm going to put this into equation form. And so how I do that is, let me take this statement here, and statement number 4 is that angle 2 and angle 3 are supplementary to each other, and I put that into an equation. So what does it mean for two angles to be supplementary? It means for them to add, their measures add to be 180 degrees. Measure of angle 2 plus measure of angle 3 equals 180 degrees. The reason for that is, this is just a definition of supplementary. Two angles are supplementary if and only if their measures sum to be 180 degrees. Two angles are supplementary if and only if their measures sum to 180 degrees. All right, so this is if and only if statement, so it goes either direction. So what am I saying right now? I'm saying that their measures sum to 180 degrees. So where do they say that they're supplementary? I set it up here in 4. Now, I'm really close to being able to substitute in angle 6 for angle 2 here, but to be able to do that, I need an equation. And so I'm just going to turn this up here. Angle 2 is going to angle 6 and do an equation for myself. So that'd be statement number 6 here, that the measure of angle 2 is equal to the measure of angle 6. And this will just be my definition of congruence. Two angles are congruent if and only if their measures are equal. I'm starting to run out of room here. This is a new problem for me. Where did this come from? Up here in 2. So my statements are getting longer and longer. That's okay. All right, so now I can actually do the substituting, which is great. So I'm going to substitute this statement what I just made. So the measure of angle 2 is equal to the measure of angle 6, and substitute it into this equation right here. So I know that measure of angle 6 is equal to measure of angle 2, so I can place that in place of measure of angle 2 here. So say measure of angle 6 plus the measure of angle 3 is equal to 180 degrees. My reason for that will be the substitution property. And what am I going to cite? Well, I need to cite the thing that I was substituting in the equation I was substituting into, which was 5 and 6. All right, and so now I've got my last thing here, which I'm really close to my statement that says that angle 3 is supplementary to angle 6. What does it mean for two angles to be supplementary? It means that they sum to be 180 degrees. And so I just need to rewrite this statement here and say that say that angle 3 is supplementary to angle 6. How do I know that to be the case? Well, I will say that two angles are supplementary if and only if, since it's definition, if and only if their measures sum to 180 degrees. Nice, I got it all on. To 180 degrees. Okay, so let me check myself here. So what I'm finishing with is two angles are supplementary. If and only if, where did I say their measures sum to 180 degrees? I said that up here in 7. So that's what I will cite. All right, so this is my proof of the consecutive interior angles theorem, which says that if two lines are parallel, then consecutive interior angles are supplementary, which was obviously a decent amount more work than my alternate interior angles theorem or my alternate exterior angles theorem. And the reason for that is because I have to do all this conversion between things being congruent and supplementary to their measures, which is a little bit tedious and it's more work involved, but it gets me to my end result. And so the great thing is that it took me eight steps to do this here, but now moving forward I can of course just use this in a proof, saves me a lot of time. And so this is the proof of my consecutive interior angle theorem.